3.6 Implicit Differentiation. So sometimes an equation only implicitly defines y as a function of x. So let's look at some examples. Here we have x squared plus y squared equals 25. Now, we could solve explicitly for y. We could solve this for y equals, and we're going to actually do that on the next slide. But if you have something like the second example, this one's very difficult to explicitly solve for y. So we're going to learn implicit differentiation now so that we can take the derivative without having to solve for y first. So if we look at that first example that we had on the previous slide, x squared plus y squared equals 25, and we go ahead and try and solve explicitly for y, we get two functions, y equals positive root 25 minus x squared and negative root 25 minus x squared. We have the top and the bottom half of our circle. We're going to learn today a way to find dy dx without having to solve for y first, and this is called implicit differentiation. The steps that we're going to use is we're going to first differentiate both sides of the equation with respect to x, and then solve the resulting equation for y prime, in other words, dy dx. In this first example, we're going to solve for dy dx using both implicit differentiation, our new way of doing things, and also the way that we used to do it by explicit differentiation, solving for y first, and seeing that we do get the same answer both ways. Let's first use our new methods. And so that said that we take the derivative of each side. So the derivative of x squared is just 2x. And now the derivative of y squared, we have to be careful. The reason that we say it's implicitly defined is because we have to remember y is a function of x, meaning y has an x within it. When we're taking the derivative of y squared, we get 2y times y prime. That's just like a chain rule right there. The y has an x inside of it. We cannot forget to take the derivative of its baby. It's a chain rule kind of thing. And then the derivative of 25, a constant, is just 0. So if we solve for y prime, 2y, y prime equals negative 2x, y prime equals negative x over y. Let's go ahead and do that explicitly. So we would get y equals plus or minus the square root of 25 minus x squared. Look at the second question. We're going to try and find an equation of the tangent line at the point 3, 4. Since we're looking at 3, 4, we're going to just use y equals the positive one, since we're definitely on the upper half of our semicircle. And so when we take the derivative, let me rewrite that as 25 minus x squared to the 1/2 power. We're going to have to use a chain rule here with the baby. And the derivative is just going to be 1/2 times the baby to the negative 1/2, subtract 1, and then take the derivative of the baby. So the derivative of this is just negative 2x. In other words, we get negative x over root 25 minus x squared. And isn't this what we said y was? Isn't that what y was? So this is the same thing as negative x over y. They're equal. So now part B says find an equation of the tangent line at the point 3, 4. So we have a point and we need a slope. Our slope evaluated at the point 3, 4 is just going to be negative x over y. Y equals the slope x minus x1 plus 4. That is our equation. And of course, we're going to get the same thing on this side since we had the same equation right there. In example 2, we just want to do this the easy way. We just want to use implicit differentiation to find y prime. So we get 3x squared plus 3y squared y prime. And then to take the derivative of this, we have a product. So we're going to have to use a product rule. The derivative of the first times the second plus the first times the derivative of the second. And the derivative of y would just be 1 times y prime. So we want to solve for y prime. Let's get all the y prime stuff on the left. Factor out a y prime. And solve for y prime. That is our answer. We have solved for y prime. So now they ask us in part B, find the tangent to the curve at the point 3, 3. So we want to evaluate this at the point 3, 3. We just stick in a 3 for the x and a 3 for the y. And we're going to get -1. And so we'll just use point slope. Y equals -1 x minus 3 plus 3. So answer to part B. And part C is asking us at what points is the tangent line horizontal. So the tangent line is going to be horizontal when y prime equals 0. And when is our fraction equal to 0? Only when the numerator is 0. So we'll just set that numerator equal to 0. And we get 6y equals 3x squared. In other words, y equals 1/2 x squared. Okay, so we know whenever y equals 1/2 x squared, we have a horizontal tangent line. So we have to find the actual points on our curve where this occurs. So here's our original equation, and let's just substitute this. So we have x cubed plus 1/2 x squared, so that's y cubed equals 6x times y. And so we're going to get x cubed plus 1/8 x to the 6th power equals 6 divided by 2 is 3x cubed. So let's go ahead and put everything on the left. 1/8 x to the 6th minus 2x cubed equals 0. I don't really like fractions, so let's get rid of them. So we get x to the 6th, just multiply everything by 8, minus 16x cubed equals 0. Factor out an x cubed. Okay, so we have x cubed equals 0 or x cubed equals 16. In other words, x equals 0 or x equals the cubed root of 16. And so they were asking us at what points, and so I'm going to just move up here. And so these are our x's and our y's. Remember, we're 1/2 x squared, so our points would have been 0, 0, or the cubed root of 16, and then 1/2 times 16 to the 2/3. And we can just leave that because we did the cube root of 16 and then we squared it. So now we're going to really have to apply. First of all, we have a chain. This is my baby. And then we definitely have a product going on over here. So let's just identify that before we even start our problem. So when we go over here and take the derivative of the left-hand side, the derivative of sine is cosine. Derivative of sine box is just cosine box times the derivative of the box. The derivative of x is just 1 plus the derivative of y is just y prime. Now let's take the derivative of the right-hand side. We already identified that it's a product rule. The derivative of the first is 2y, y prime, times the second, plus the first, times the derivative of the second. Remember, the derivative of cosine is a bad sign. And so we need to solve for y prime, so we are not done, unfortunately. Let's go ahead and multiply the left side out. So we have cosine x plus y prime cosine x plus y equals 2y prime cosine x minus y squared sine x. Let's pull all the y prime stuff on the left. And let's pull everything else on the right. And so we can solve y prime equals negative y squared sine x minus cosine x plus y all over the bottom. And so you may have gotten the other way around thing. If you don't want so many negatives, take a negative out of the top and a negative out of the bottom. Either one is equally as good. I just factored a negative out of the top and out of the bottom in this one.
This question here asks us to find the equation of the tangent line to the curve x squared plus xy plus y squared equals 3 at the point 1, 1. So in order to find the equation of a line, we need a point. We've got a point, and we need a slope at that point. So we've got to do that. In order to find this slope here, let's go ahead and use implicit differentiation because it's not easy to solve for y equals in this problem. So the derivative of x squared is 2x plus, how do we find the derivative of xy? Well, that is x times y. So we need a product rule. Don't forget that. So the derivative of xy, we need the derivative of the first times the second plus the first times the derivative of the second. And the derivative of y is just y prime. So that's the derivative of that guy. And then plus the derivative of y squared is 2y times y prime, right? Because that y has a baby inside. All right, and that equals, what's the derivative of 3? Well, the derivative of any constant is just 0. So in our past examples, what we've been doing is we've been solving for y prime at this step. But in this particular problem, I need the slope at 1, 1, right? So there's no need to actually solve for y prime. I can just actually put in the point right now to make my life easier and then solve for y prime. Okay, because I just need y prime at this specific point. I don't need a general equation for y prime. This problem's not asking me for it. So I'm just trying to simplify my life here. Okay, so let's go ahead and do that. So using this, 2, x coordinate is 1, plus 1 times y, which is 1, plus x is 1, times y prime, which we don't know yet, plus 2y, 2 times 1 times y prime equals 0. So we've got 2 plus 1 plus y prime plus 2y prime equals 0. So 3 plus 3y prime equals 0. 3y prime equals negative 3. Y prime equals negative 1. So our slope at the point 1, 1 is just negative 1. So now it's pretty easy. Y minus y1 equals slope times x minus x1. In other words, y equals negative x minus 1 plus 1 will be the equation of our tangent line.
This is a piece of vocab that you need to know, orthogonal trajectories. Two curves are called orthogonal if at each point of intersection their tangent lines are perpendicular. So again, we're talking with perpendicular tangent lines. So we're going to do an example. The equation xy equals c represents a family of hyperbolas, and then x squared minus y squared equals k is another family of hyperbolas with these asymptotes at plus or minus x, and we want to just show that these families are orthogonal trajectories of one another. So what do we want to show? We want to show that their slopes are negative reciprocals of one another, that they're perpendicular. So slopes, again, are the derivatives, y prime. So let's go ahead and use implicit differentiation to find y prime of this one. So let's just call this A and this B. So the derivative of xy, we're going to need a product rule where this is the first and this is the second. Derivative of the first times the second plus the first times the derivative of the second. The derivative of a constant is just 0. Go ahead and solve for y prime. Let's do the same thing for this one. We get 2x minus 2y, y prime. K is a constant, derivative is just 0. Y prime equals, let's do 2y, y prime equals 2x, y prime equals 2x over 2y, or x over y. And so we have shown that they are orthogonal trajectories. This slope is a negative reciprocal of this one. The figure in the next one is just showing what these two curves are, and I think it's pretty cool to look at. So at each point you have this tangent line is perpendicular to the tangent line on the blue curve. So that's what we're saying. Inverse trig functions, you do need to know the derivative of inverse trig functions for the AP exam, and this is just another example of implicit differentiation. If you want to find the derivative of y equals the inverse sine of x, remember this is the same thing as saying that the sine y equals x. And so if we took the derivative of this, the derivative of sine y is just cosine y, but remember to take the derivative of the baby, and the derivative of x is just 1. So y prime equals 1 over cosine y. Now, I want this answer with all x's in it, and my problem is I have a y here. So remember your trig identities that sine squared x plus cosine squared x equals 1? Let's just say now sine squared y plus cosine squared y equals 1. Same thing, right? Let's try and solve for cosine y. We get cosine squared y equals 1 minus sine squared y. In other words, cosine y equals the square root of 1 minus sine squared y. Didn't we say that sine of y equals x? Isn't this the same thing as 1 minus x squared? Do you need to be able to come up with this on your own? No. This is just neat to see. We're just going to get exposed to these kinds of things this year. So this is the same thing as 1 over the square root of 1 minus x squared, meaning that the derivative with respect to x of the arc sine, which is what we just found, the derivative of that is just 1 over root 1 minus x squared. So if you look on your next slide, you'll see that these formulas you need to know. In addition, you need to know the formula for arc cosine, but you're going to find that in your homework. If you could please write that formula on this slide after you have done the homework problem for reference. You need to know those formulas for the AP exam. So just one last example here. Let's try and differentiate in A. Can we please write that? Remember, I don't like to use the quotient rule if I don't have to. So let's rewrite this like that. And so we clearly have a chain rule where that's our baby. And the derivative is going to be negative box to the negative 2 times the derivative of box. The derivative of arc sine is just 1 over root 1 minus x squared. You just have to memorize that. And so that is our final answer right there. So in part B, we have y equals x times the arctan of root x. I'm just going to rewrite that as x to the 1/2 power. So we see that this problem has a bit going on. First, we identify a product rule first, and here's our second. But within our second here, we see that we have a chain rule going on, where that's our baby. So let's just go one step at a time. Let's first do the product rule. The derivative of the first times the second plus the first times the derivative of the second. Remember, we just learned that the derivative of arctan is 1 over 1 plus x squared. So now we have the derivative of the arctan of root x. So instead of our x, we're going to replace it with a x to the 1/2. So all we did was replace our x with an x to the 1/2. And then we have to chain it. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Now I encourage you to just leave that answer. As some of you have seen on your quizzes, you've tried to simplify it and you've simplified incorrectly, then you would have lost the points. This you would get full credit for. I am going to simplify it for you, and I would just encourage you to simplify for practice on homework, but on tests and quizzes, just leave this because the AP exam would accept that. I'm going to simplify it further in case this was a multiple choice question and that answer choice wasn't sitting there waiting for you. What do we have? We have an x and we have a root x on the bottom, which would leave us with a root x on the top. We have this 2 times 1 plus root x squared is just x. And that's our final answer. So that's it for this lesson.